Hello Pre-Calc kids, welcome back to another lesson in AP Precalculus. This is Mr. Bean, and today's lesson is going to be focused in on hyperbolas. Hyperbola is the last conic section that we're going to deal with in this unit, and there are some similarities with the way it looks as to our last lesson on ellipses, but the graph itself is very different. So you can see here a hyperbola has two separate branches. They'll either be moving left and right, or opening left and right, or you would have a vertical hyperbola that is opening up and opening down. So how do we know if it's a vertical or a horizontal hyperbola? It all depends on which term, the x term or the y term, is positive and negative. So notice here the difference between, the only difference in fact, between the equation of a hyperbola and ellipse is this thing right here, subtraction. When it's subtraction, it's a hyperbola. If it was addition, it's an ellipse. Now on this page, I'm going to show you very briefly the idea of what these values do. But right here in the middle would be the center of the hyperbola. And that's just going to be at the value h comma k, right? We've done this lots of time. That's supposed to be a k, and even though it's really sloppy. So h comma k, and that would be the same here. That right there is h comma k. Now what else we have going on is the distance between these things. So that distance right here from there to this vertex, that distance here is going to be one of these values, either a or b, not a squared or b squared, but it's either going to be a or b. And the way you know which one it is it's just the one that's underneath the positive term. So you see down here, which squared term is positive? If the x term is positive, it's a horizontal hyperbola. If the y term is positive, it is a vertical hyperbola. So in this one, the y squared is positive, so it's a positive in front here, so it is opening up. Now normally, we wouldn't write it like this. You'd probably just switch these around and say the y squared minus the x squared. I'm only doing it this way because that's the way College Board had it written out in their standards. And also, here's another thing. This is going to be a little confusing for those of you who are coming here after learning it from a textbook or reading something, and that has to do with a squared or b squared. Now, there is no restrictions on a squared or b squared. It doesn't matter which one's larger or smaller. That's different than an ellipse, right? Ellipse, it mattered which one's larger or smaller. It doesn't matter for hyperbola. Most textbooks will switch around the a and the b depending on the vertical or horizontal. I'm telling you that it doesn't matter which one is a squared or b squared. These are just numbers. The a and b just help us represent or designate something. What I want you to understand is that this axis right here, if I go all the way across here, this is the transverse axis. Okay, so I want you to label that transverse. Transverse. Transverse axis goes from vertex to vertex. It transverses the vertices. That is what that is right there. So here, the transverse axis would be from vertex to vertex. It transverses the vertices. Goes right through the center. That's the transverse axis. The length of the transverse axis is always double the value of, so in this case, it's 2a. So this one, it would be, the transverse axis is 2a. In this one, the transverse axis is 2b. Now, I don't want you to get caught up on which one's a and which one's b. So really what you just need to figure out is if it's up or down hyperbola, then I'm dealing with the y value. So it's that right there, the number underneath that. The square root of it doubled is the length of the transverse axis. Okay. All right. Confusing enough for you? Just wait. We got more. All right, so let's move on to some of these things here. This is just the quick little definition of a hyperbola, some fancy math speak. Just recognizing the slight difference between a hyperbola and an ellipse is that it's the difference between the points from a focus. So if I just choose a point here, the distance to a focus, difference to the other focus, excuse me, the distance, not difference, the distance to the focus, distance to this focus, you take the difference of those two, and that's all going to be a constant value. Everywhere along the hyperbola, it's going to be the same thing. The difference between them, absolute value of the difference. Whereas with an ellipse, it was the sum of those two distances would be equivalent. Okay, so this is not vital to understand to be able to work with hyperbolas, but that's just the kind of the definition of hyperbola. All right, now let's get to the confusing page. So the first time you start working with these things, this looks really, really confusing. It won't be that bad, trust me. We'll get into the practice of it. So let me just point out some things. I already talked about this transverse axis thing. Here it's 2a, right? From the center to the vertex is 2a. Don't worry about these imaginary lines. I'll get to that in a minute. So that distance here is a, whereas this distance here is a b because it's with a value underneath the y. Do not get stressed out about am I supposed to use a or supposed to be b? What I would focus in again on is if it's horizontal, then use the number underneath the x. If it's vertical, then use the number underneath the y. That's the number you're going to focus in on to help you figure out the transverse axis. Okay, so what about the foci here? The foci is very similar to what we did with ellipses, except that, notice this. Now it's c squared equals a squared plus b squared. Oh no. So it's actually it's just the Pythagorean theorem is what this is. But whereas in ellipse it was a squared minus b squared, now it's a squared plus b squared over here. Now here's the nice thing about that. What that means is you don't have to keep track of which one's a and b, because you're adding them and it doesn't matter which order you do it in. So it's just a squared plus b squared. So you just take these two numbers that are on bottom and you add them together, and that'll give you the c squared. I'm going to show you some more examples of this in a minute here. The asymptote part, don't worry about this yet. I'm going to show you this. In fact, that's really confusing what this is coming from. This is the part to focus in on, the conjugate axis. Okay, so here's what the conjugate axis is. Whichever one you used for the transverse, the other number is going to help you get the conjugate axis. So what I'm going to do here is do an imaginary line up and an imaginary line down. In this case, that would be B and B. It's 2B. Okay, so now do that here too. So an imaginary line this way, an imaginary line this way. Now in this case, it's A and A. Again, I'm not too stressed about what the variables are. I just know if I'm using transverse axis, it's transversing the vertices. This one would be left and right, so it's the number underneath the X. Up and down here, it would be the number underneath the Y. So I got to use the other one to do the conjugate. All right, now what does that give us? What is this for? That helps us create an imaginary little rectangle. So watch this here. Let's see if I can do this right. If I create a box, I said box, I should have said rectangle. So this rectangle is from vertex to vertex is going to be the value of double whatever's underneath that. In this case, it would be an A. The up and down portion of this rectangle, for this one, this is the conjugate axis, and that determines how high up and down the box is, or the other direction. Now, the reason that's so cool is because when you create this box with using the A and B values, that helps you set up the asymptotes. We haven't even talked about asymptotes yet. The asymptotes go from corner to corner. Let me show you. So from this corner here to this corner here is the asymptote, and then you just extend it out. That's what those dashed lines are for. So I'll do another one. So I go from this corner to this corner. That's the asymptote, and then I just extend it out. And the reason these asymptotes are important is because these slant asymptotes are what the branches of the hyperbola approach. So that's what this represents here. It's the approaching of the graph approaching these asymptotes. So a hyperbola is not two parabolas. This is not a parabola. A parabola just kind of continues to grow up and up and up and up and up. This one starts to approach the attributes of this line. So it gets closer and closer to this slant asymptote there. Okay, confusing enough? Yeah, let's just practice this. I think it won't be too bad after we practice a couple and you'll get this. All right, so let's start off with this one. First off, the center. All right, the center is going to be at h comma k. Now remember, the h is always with the x. So in this case, it's going to be positive 2 and negative 1. So I get the opposite of that one, opposite of that one. Simple enough. There's my center. Now, is it a horizontal or a vertical ellipse? Which term is positive? The y term is what's being positive here. So since the y term is positive, this is a vertical, I said ellipse earlier, sorry. This is a vertical hyperbola, not ellipse, vertical hyperbola. So that tells me find the length of the transverse axis, the one that transverses the vertices. So since it's vertical, I'm going to work with the value underneath the y. So what I want to do is, that is the 25, I want to take the square root of that. So the square root of 25 is going to equal 5, and then I'm going to double that value of 5 to give me 10. So 10 is the length of the transverse axis, or 5 away from the center is where the vertices are. 5 away from the center going up and down. All right, how about the conjugate axis? So this helps us with this imaginary rectangle that we're going to create. So now I used the 25 on the other one, so now I'm just going to use the 9. So I take the value of that one. Square root of 9 is 3. Nice and simple, nice perfect square numbers. So then I'm going to double that. So 2 times 3 gives me 6. 6 is the length of the conjugate axis, or in other words, 3 away from the middle, going left and right, because the transverse is up and down, conjugate will be left and right. So now when I go to my graph, I'm going to go ahead and start sketching the graph. I don't need the foci to be able to sketch the graph. I'm going to show you how to get the foci, but we don't even need those to create the graph of this. So let's start off here. What was I saying? The center's at 2, -1. So go ahead and put that 2, -1. There's my center. Then I have, it's going up and down, and it's 5 away from this center point. So I'm going to go up 5, 1, 2, 3, 4, 5. I'm going to go down 5, 1, 2, 3, 4, 5. There's my vertices. Okay, and then what else do I need? I have my conjugate axis. It's a distance of 3. I'm going to use a different color here just to show that. So I'm going to go 1, 2, 3, put a little mark. 1, 2, 3, put a little mark. And now what does that conjugate axis help me do? This is where you get to create an imaginary little rectangle. So I'm going to go here, notice, and I'm going to match it up with my conjugate axis and my transverse axis. All right, there we go. So I've created my imaginary little rectangle there. And now that rectangle then helps me sketch the slant asymptotes. So I'm going to go from this corner of the rectangle to this corner of the rectangle. Okay, there's my slant asymptote. And then I just extend it out. Now I'm using a computer, so this is a lot easier for me to do. You'll probably have to use some type of ruler or something to create your slant asymptotes. And then let me do this other one. And just kind of extend it down as far as you can on the page. I'm going to bring these up even further just to help me sketch it. Okay, once I have all this, now I'm ready to sketch the graph. This is all I need. The foci is, I mean, it's important, but it's not necessary to be able to sketch it. So what do I do from here? There's the vertex. It's opening up, and I'm just going to get closer and closer to these asymptotes. It gets closer and closer and closer to that asymptote because it helps me with the end behavior there. So, oh, that was bad. I'm curving. Let's do that again. That looked bad. And not much better, but closer. Okay, so you're getting the idea. We're just sketching, and the slant asymptotes help me to guide where my graph is going. So I do that on the top, and I do that on the bottom. Okay, that's the graph. So you can see here I have my transverse axis. That length is a total of, what did I say? 10, right? So up 5, down 5. The conjugate axis is a total of 6. Left 3, right 3, so a total of 6. And then I can sketch it. Now let's do the foci just so we can see where those foci are. So remember, foci helps us with, the equation is c squared equals a squared plus b squared. Do I care which one's a and b? No, I don't. 25 and 9, it doesn't matter which one goes where. So we're just going to say c squared is going to equal 25 plus 9. So c squared equals 34, or c equals the square root of 34, plus or minus, but just the value of c is square root of 34 away from the center. Okay, so that's approximately, without my calculator, square root of 36 is 6. So this is going to be, I don't know, what, 5.8, 5.9, something like that, around that value. I'm just estimating. So it's going to be from the center 5 point something, just a little bit short of 6. So there's my center, or excuse me, there's my focus. There's a focus right there. Down 5.8, almost 6. There's another little foci there. So where are they? You would say Well, if my center was at 2 comma negative 1, then I'm going to have, my foci are going to be at 2 comma, I say negative 1 minus the square root of 34. And then the other point is at 2 comma negative 1 plus the square root of 34. And then that would give me the exact point. I could also do a decimal. I could get a calculator and plug that out, but I don't have to use the decimal if I just want to do the exact form there. So again, you can see here the foci, it just helps to be able to see where it would be, but it's not necessary to be able to sketch the whole graph of it. Let's do another one. All right, for this problem, we're doing the same thing, except that it's not yet in the standard form we need. So what I need first is it has to equal 1 over here on the right. So I'm going to divide everything by 16. And when I say everything, I mean each term. So this is a term right here, this x squared, and then this whole thing is a term. So I divide by 16 there. So what am I left with? I have x squared over 16 minus, now this, treat this like a fraction. The 4 and the 16 reduced to 1 and 4. So I'm left on top with y minus 3 squared all over 4, and then this equals 1. Now I have this nice standard form, and I can start identifying what I need. The center, what's with the x? 0, comma, and then the y is a 3. Is it a horizontal or vertical? Which one's positive? The x is positive, so it's going left and right. It is a horizontal hyperbola. I feel like he keeps saying ellipse. Bad habit. I hope I wasn't saying ellipse right there. Horizontal hyperbola. Find the length of the transverse axis. So since we're moving, I'm just going to even sketch this just to remind myself. This is what it's doing. It's opening left and right. Find the length of the transverse axis. So I'm trying to figure out what is this length here from the vertex to the vertex. And that is going to be always using, if it's horizontal, I'm using underneath the positive term for the transverse axis. So it's the square root of 16, which equals 4. And then I double that. So I'm going to do 2 times 4 equals 8. So 8 is the length of this whole thing, meaning from the center to the vertex is 4. And from the center to the other vertex is also 4, for a total of 8. Find the length of the conjugate axis. So remember, that's like this imaginary value up here and down there. The length of the conjugate axis is the other number that I didn't use. So I'm going to go square root of 4 equals 2. So that value is 2. And then I'm going to double that, and I get 4. So that distance there is 2, and that distance down is 2. All right, so that's the visual of what I'm working with on this. And that's everything I need. Right? I could sketch the graph now. The foci we're going to practice with, we don't need the foci to be able to sketch the graph. All right, what was the center again? Center is 0, 3. All right, 0, 3, 0, 3. There's my center. And then it is horizontal, so left and right. So I'm moving left 4 and right 4 for a total of 8. So left 4, 1, 2, 3, 4. 1, 2, 3, 4, total of 8. And then I'm going to go up and down 2 for a total of 4. I'll use a different color here. Up 2, down 2. That helps me with my conjugate axis. Now I'm going to draw my rectangle. All right, there's my rectangle for my conjugate axis and my transverse axis. And then let's create my asymptotes. I go from corner to corner of this rectangle. So corner to corner, extend it out. You can go pretty far on the page if you'd like to extend your axes out, your asymptotes out. And I like extending them out far because it just helps me to create a better graph. And then I'll extend this one out pretty far. Okay, so there we go. And then we can quickly sketch the graph. Okay, there's my hyperbola with my 2 branches, left and right. And now let's do the foci. So the c squared is going to equal a squared plus b squared when it's a hyperbola. And with an ellipse, remember, it would be minus. So I don't know what the c value is yet, so c squared equals. I know that my a and b are 16 and 4. Doesn't matter which one's which. So I'm just going to say 16 and 4. C squared equals 20, which gives me c equals the square root of 20. Now, yeah, I could simplify this down to something else. I'm going to roughly say it's approximately, let's use a decimal approximation. 16 would be 4, 25 would be 5, so it's right about the middle of that, right? So I'm going to say it's 4.4 something. That's probably a rough estimate. Okay, that just helps me know that 1, 2, 3, 4 point something. There's my focus there. And then 4.4 away, there's my focus there. So it's really close to the vertex on this. I know, so exactly where are they? It's, the center was at, where was the center? The center was at 0, 3. So I'm adding and subtracting 4.4, or in other words, square root of 20, to the x value, right? I'm doing it to the x value. So I'm going to have negative square root of 20, comma 3. I can't even remember what I'm doing. And the other one is square root of 20, comma 3. All right, that's where those coordinate points are. That's where the foci are. Okay, let's move on. 2 more questions and then we're done. So now we're not going to graph them. We're just going to use the information that we have given, and we're trying to come up with an equation of the hyperbola. So we have a foci at this point and at this point. So that helps us know the center. It gives us some other information, transverse axis, length, but let's figure out where the center is. So the center has to be at the average of where the foci are, right? So, well, 0, 0 is going to be the same, 0, 0. And then what about, we're halfway between -4 and 2. If you can't just kind of think through it and figure it out, you can always do quick little arithmetic here by taking the average, and then that makes it really easy. So the center is at 0, the average of the y values is -2 divided by 2, which is just -1. So that's right in the middle for the center. All right, so now what else do we have? We have the transverse axis. Oh, wait, let's do this. Let's just do a quick little sketch here. If 0, -4 is down here and 0, 2 is up here, that tells me that the hyperbola is opening up and down. Now that's important because that tells us it's a vertical. So when I do my subtraction, which one's positive? The y is positive. So I have my fraction, and the y has to be the one that's here, with the x being here. Okay, now let's apply the center. 0 with a -1 is 0 plus 1, quantity squared. And this one is just a 0 with the x, so I'm just going to say x squared. And then this has to equal 1. Okay, we're almost done. All I need now is the bottom here. The transverse axis has a length of 4. So what that tells me is that this number here, whatever that value is, it's, how do I say this without using A and B? I'm trying to tell you. So this whole thing there to there is 4. So half of that is 2 and 2. So it's 2 squared, right? Yep. So that value is a 2 from halfway from the center to the vertex. So that is that number there. Okay, so what else do I have? I've got c squared equals a squared plus b squared. So I have found either the a or the b here. Again, I don't care if it's a or b, but I know one of them. I don't know the other one. I need to know what this one is. So let's say if I know c, do I know c? Oh yeah, I didn't write it out here. So what is c? The c value is going to be the center to a focus. So that distance is 3 to both of them. So it's 3 squared. And then here, a squared, it doesn't matter if I do this as a or b because I'm just going to find the other one. So I'll just use it as a, it's fine. So 2 squared plus b squared. So 9 equals 4 plus b squared. 5 equals b squared. I don't need to know what b is. I just need to know what b squared is. So that one is going to be right here, a 5. So now I can write my final answer. Y plus 1 quantity squared over 4 minus x squared over 5 equals 1. There's my answer for the standard form of the hyperbola. Last problem. You guys are doing well. I know this lesson's long. We're almost done. Standard form, identify the center and orientation. So what do we get here? We need the x's together, the y's together, and then the constant to the other side. So I'm going to say x squared, and then the plus 2x. So I'm arranging this with the x's together. Now where's the y's? I have a -9y squared minus 36y, and then the only thing left is to get that -71 to the other side, makes it a +71. Now the reason I've done this is so that I can then start completing the square. So I have x squared plus 2x. Now let's complete the square of these two terms right here. half of this value is 1. Square it, you get 1. All right, I'll come back to that. Now here, I cannot complete the square because I have a term in front of the y squared, right? It has to be a 1 in front of the y squared, so I'm just going to factor out that 9, and that leaves me with y squared. Factor out a negative 9, I get a plus 4y. And now I can complete that square. Let's use a different color here. Half of 4 is 2. Square 2, and I get 4. So I'm going to put that in green just to keep track of the values that I'm using. Equals 71. Okay, I've completed the square on the left side. Now I have to balance my equation. What did I add on here on the left side? I added a 1, so I have to add a 1 here. And then if I look at the green, I added a 4 here. So you think, oh, I'm adding a 4 here? No, I'm adding a negative 36. Where'd that come from? It's 4 times negative 9. So I actually put a negative 36 on the left side. That's where that comes from. Right, now we can factor this thing. This is a nice, perfect square trinomial, x plus 1 times x plus 1. So x plus 1 quantity squared minus 9 times. This becomes a y plus 2 quantity squared. So again, I'm just completing the square here. Equals, I simplify this all out, and I get on the right side a 36. In order to get this into a standard form, which I'm working towards, I'm trying to get a standard form, it has to equal 1. So I need to divide each term by 36. So divide that by 36, divide that by 36, divide that by 36, and now I get my standard form, final answer of this. So this is like a fraction that I reduced. I reduced the 936 to 1 over 4. And there's my answer, standard form. So is this, what's the center? Let's write that out. The center is at negative 1, negative 2, negative 1, negative 2. And which orientation? Is it horizontal or is it vertical? So which one's positive? The x is being positive. So this is a horizontal hyperbola. Okay, we finished this off. Sorry the lesson was so long. There was a lot of information we're covering. This is Mr. Bean signing off. Rock that master check, and I will see you back in our last lesson for Unit 4A.